Okay, so in this lesson today, we're going to talk about chemical equilibrium. All right, so what is chemical equilibrium? And I've got for us an equation where nitrogen gas plus hydrogen gas gives us ammonia gas. And we'll notice here we don't have a single arrow. We have this arrow where it's going to the right and to the left. So up to this point in time, we've been making the assumption that all equations and reactions go to completion. But the reality is most do not go to completion, and that's where chemical equilibrium comes in. So to define chemical equilibrium, we say the forward reaction and the reverse reaction are occurring at the same rate. So what does that mean? The forward reaction is when I take reactants and make products. However, products will then decompose, in this case, because this is a decomposition in the opposite direction, to make what was our reactants. So what I have in a system, I have nitrogen and hydrogen making ammonia, but ammonia is also breaking down to make hydrogen and nitrogen. So we have a forward and a reverse reaction happening at the same time. Now, when at equilibrium, the rate of the reaction is the same, meaning the time it takes for products to be made is the same as the time for reactants to be made. All right, so our concentrations of the reactants and products are not necessarily the same. It's the rate. We're talking about how long that process takes. All right, the concentration of reactants and products is used or is called our equilibrium position, which is used to determine if products or reactants are favored. So we can look at the equilibrium position and we can say that products are favored, meaning the reaction would prefer to make products, or reactants are favored, meaning the reaction would actually prefer to stay as reactants and not go into products. So we can make that determination as well. So at equilibrium constant, this is going to be our ratio of product to concentration to reactant concentration. Now when we talk about our equilibrium constant, that is K subscript EQ, KEQ. Now, KEQ is our general equilibrium constant. And now, this is kind of like a car. So if we were to give an analogy and I would say a car, there's a bunch of different types of cars. There's Ford and Chevy and Tesla and Nissan and Toyota and all kinds of different cars. Okay, so different model cars, but they're still cars. So that's what this KEQ is. For the purposes of our class, we are going to concentrate with only K in terms of KC, which is concentration, C for concentration. All right, so we're not going to look at any other types of Ks. We're going to look at it only in terms of concentration. So think about if you drive a car, what car you drive, okay? That's just your car, all right? You're not driving a whole bunch of other cars. You're just driving that one, all right? So this purpose of this class, we're going to just drive one car, and that's going to be in terms of concentration. All right, so to do our KEQ, and in our case, you could write a C, so we'll do it both ways here. That is the product, and it is going to be raised to the mole over our reactant, raised to the mole. Now, when we look at an equation, we have to look at it in terms of only solid, liquids, or gases. Okay, so when we look at an equation, we look at it in terms of, let me start over. only gases and aqueous. So I'm sorry, I just confused you. You can only use the gas and aqueous. Why is that? Solid and liquids do not change the concentration of a substance enough to affect the KEQ, but gases and aqueous can. Now, let's think about this in terms of a logical position. If my numerator is greater than my denominator, so if I have a larger value, that means I have more product than in the reactant. So if I have a larger numerator, then that means my KEQ value is going to be greater than 1. And if my KEQ value is greater than 1, I have more what? I have more products. So products are favored. All right. And if I have more reactant on the bottom, that means my denominator is a larger value. So a smaller value divided by a larger value gives me a decimal. So my KEQ is less than 1. So if I have more reactants, then that's going to mean my reactants are going to be favored. And this is what we are talking about when we're talking about our equilibrium position. What is favored? Okay, is KEQ greater than 1 or is KEQ less than 1? So let's go ahead and let's do us a practice example with our solving for K. All right, so we have at equilibrium a 2-liter flask contains 0.15 moles of hydrogen, 0.25 moles of nitrogen, and 0.1 moles of NH3. Let's calculate KEQ. So step 1 here is we have to have a balanced equation and we have to set up our K value. My products are only ammonia. And how many moles of ammonia gas do I have? 2. So it is raised to the mole, which in this case is a 2. Over reactants. I have 2 reactants. I have nitrogen and I have hydrogen. Now, each one of these is raised to their mole as well. I have 1 mole of nitrogen, so this is raised to the first power, and we don't write a 1, remember that's understood. I have 3 moles of hydrogen, so my hydrogen is raised to the third power. So there is my equation. NH3 squared over NH3 squared over N2 times H2 to the third power. Now, if we're looking at this in terms of concentration, all right, so, and that's going to be a C, we could actually, instead of putting in this KEQ, we could actually further define it as a KC value, all right, in terms of concentration. And now we know that concentration is molarity, and molarity is defined as moles over liters. So I now have to set up my molarities. So hydrogen has 0.15 moles, and my volume is 2 liters. So the molarity of hydrogen is going to be 0.075, and then my nitrogen is 0.25 moles. Again, the same volume, 2 liters. So that's going to be 0.125 molar, and these are molar. All right, and then my NH3 as well. Okay, so it has 0.1 moles with the same value. So my NH3 is 0.05 molar. So now I have my 3 concentrations, which I can then plug in. So NH3 has a concentration of 0.05. And we are using brackets. Concentration does use brackets. Please do not use a parenthesis. All right, N2 has a concentration of 0.125. And my H2 has a concentration of 0.075. And we are going to cube that value. All right, so when I plug this into my calculator and solve, I find that I get a value of 47. Now, our K's typically have two sig figs, okay? So two values. So what does this mean? This means I had more products than I did reactants because a larger overall value divided by a smaller overall value gives me a number greater than 1. So that means that products are going to be favored.